She needs to hire a carbon project manager who will be able to accurately quantify the carbon she's purchasing. The most reliable way that her carbon project manager can do this is through the use of light detection and ranging data, also known as Lidar. We collect Lidar data by flying a plane or drone over the forest canopy with a scanner that emits laser pulses that measure the height of the forest very accurately. This creates a 3D point cloud data as is shown in the middle of the slide. The way that we conventionally use this point cloud data to estimate forest carbon is by converting it to a series of statistical summaries such as mean height or the 95th height percentile of the data. These statistics are called Lidar metrics, and they can be easily plugged in to different types of models to estimate forest carbon. But there's one important limitation with these Lidar metrics, and it's that they condense this rich 3D representation of the forest to a short collection of statistical summaries. So how can we make better use of this rich data format to model forest carbon and avoid the information loss inherent in Lidar metrics? With the advent of deep learning, we can now apply neural networks to model the point cloud data directly and generate forest carbon predictions. In my research, I hypothesized that by using a deep learning neural network to harness the point cloud data directly, we will be able to generate more accurate forest carbon estimates compared to an approach using Lidar metrics. Neural networks are able to generate predictions by learning complex nonlinear patterns in a variety of different data inputs. For example, ChatGPT can take a text prompt containing 10,000 words and return an answer, and your iPhone front camera can take a picture of your face with 12 million pixels and then identify who you are from that picture. A neural network applied to point cloud data functions in a similar way. In my research, I performed a comparison between a point cloud deep learning model applied directly to Lidar data compared to a similar model that used Lidar metrics. And we observed that the point cloud deep learning model reduced carbon estimate error by 22%. So overall, this approach provides a promising tool to help improve the accuracy of carbon models. Over the past 50 years, research investigating forest carbon modeling has advanced in leaps and bounds. However, many forest carbon projects still do not reach accuracy requirements in order to be viable. So deep learning may provide a useful tool to make forest carbon estimates more reliable. Overall, we should continue to find new and innovative ways to answer the question, how much carbon is in the forest?